Hello everyone. Assalamualaikum to the Muslim and a very good morning to all of you for Akid, for Baiduri, for Citrin. So today we continue with our lesson with Physics Form 4, 12th of October 2021, a day of Tuesday. So how's your Tuesday so far? I hope you're having a good day. This is Ong Jeng, right? Okay. So those who would like to join me in the studio, you can click on the studio link here if you get good internet connection. Okay, and then for the attendance form, later you can fill up. Okay, the attendance form for today. You don't have to upload any works. Okay, students. So if you are ready, please get yourself comfortable. Sit in the most comfortable way and get ready with your books and stationery. So as for today, we are going to continue with the discussion on exercises on reflection first, reflection of wave. And then later on, if we have enough time, we will proceed with 5.4 refraction of wave. Before that, can you respond to me if you can hear me clearly? Can you give me a sign if you can hear me clearly or not? Am I sound good to you? Dengar cikgu dengan jelas tak? Okay, boys and girls. Can you hear me clearly? You may respond at the live chat. So I want you to participate actively in this discussion so you can share your answer later on or any opinion or any question in the live chat. Okay, Ong Jeng is here in the studio. Who else would like to join me? You can click on this studio link. Okay. Okay, so if you are good to go, I hope you're ready with your workbook. Please turn to page 132. Okay, 132 exercises on reflection of wave. So we have discussed reflection of wave in detail last week in two sessions. So I hope you are clear with reflection of wave. And let us test your understanding by looking at the exercise or the questions here. So without further ado, I hope you have tried to do this question. Have you tried all of them, students? Page 132 until 137. Sudah cuba ke di rumah? Ong Jeng, have you tried the question? Okay, so class, let's check on the question on page 132 first. So what do we have here? Okay, I hope you can see my slide clearly. Okay, you are given with this diagram. Okay, you can see this says the apparatus and material shown in diagram 5.10, a diagram related to reflection of water wave. So we can create reflection of water wave by using ripple tank and its accessories. Okay. Okay, then you have to complete the notes given about ripple tank. So the first one, 1A, ripple tank is an apparatus which is used to generate water wave, as I mentioned just now, and to study characteristic of water wave. We are not only use ripple tank to study reflection, but also we can use reflection to study the properties of wave and phenomenon related to water wave, for example, refraction, diffraction, and interference of water wave. Okay, so the first part. Okay, we can use stroboscope. Okay, stroboscope is used to freeze the motion of the wave. So when we on the vibrator, the wave is started producing. And if you want to draw or you want to sketch the pattern of the wave, so we can use stroboscope to freeze it. So by then we can discover the pattern clearly. So if you don't ever see how does stroboscope looks like, actually you can Google from the net. And this is the old school stroboscope which we are using in the laboratory. Bentuk dia macam ini. It has a roller. Okay, roller here consists of a few slits and then there is a handle. So the roller we can spin. So when we spin the roller, it will freeze the wave. It will appear to be freeze. So we can observe and sketch or draw the pattern of the wave produced from the activity. Okay, so you write there stroboscope used to freeze the motion of the wave. Okay. Hi Ong Cheng, welcome to my studio. Okay, then let's check on question C. Okay, on question C, okay, what is the question? So what is an imaginary line or plane in which the vibration of every point on it are at the same distance from the sources of the wave, or the line that join all point along the crest of a wave. So we learned this earlier, students. The imaginary line which joining all points in the same phase on a wave, where the imaginary line is called as wavefront. Okay, Hai Sin Wei. Okay, again, you can respond to the question by sharing your answer in the live chat. Okay, so the answer is wavefront. Okay, for C. And then how about D, students? Okay, how about D, students? For the direction. Okay, they ask you for the direction of propagation. If you remember from our previous discussion, direction of propagation of water wave are perpendicular to the wavefront since it is a transverse wave. And remember, water wave is a transverse wave where the direction of propagation is perpendicular to the wavefront. Okay. So I hope you are doing good so far. So far, nothing difficult, only a basic understanding on reflection of water wave. Okay, and then E, let's check on question E. Okay, for question E, okay, for question E, there are two types of wavefront produced by ripple tank. Actually, when we are using ripple tank, we can produce two types of wavefront depend on what type of dipper we are using. Okay. Okay, I have a few friends here. I add them to the stream first. We have Hong Cheng and Nicholas. Okay, you can open your mic if you want to answer verbally. Okay. So question E1, the first type. Okay, the first type of wavefront we can produce circular wave. Okay, we can produce circular wave if we are using a spherical dipper. Okay, where is the spherical dipper? You can see in this diagram. So we fix a spherical dipper here on the ripple tank apparatus. So when we switch on the vibrator, it will produce circular wavefront. Okay, circular wave. And then second, students, when we are using a straight dipper or a plane dipper, and then later on we can produce plane wave, okay, or plane wavefront. So where is the plane dipper? This is it. Okay, this is the plane or straight dipper. So we on the vibrator or the dipper, so it will started producing plane wave, propagating in this direction, which are the direction of propagation perpendicular to the wavefront of the plane wave. This one also for the circular wave, the direction of propagation is always perpendicular to the circular wavefront. Okay, so are you doing good so far, students, boys and girls? So I hope you can check on the answer. So now we go to F. Okay, question F. So for question F, it states here, image of water, okay, produced by a ripple tank consists of, okay, consists of a successive mean one after another, okay, one after another mean continuously, successive, dark and bright fringe, okay, successive, dark and bright fringe. So where is the image? Okay, this is the image. Okay, as you can see from the ripple tank up there. Okay, you can see the image is produced down here. It is consists of successive bright and dark fringe. Okay, so you write there bright and dark fringe or dark and bright. Anyone first will do. Okay, so what is actually this dark and bright fringes represent? Okay, how does the bright and dark fringes represent at the screen of the ripple tank? So this is the explanation given on page 133 in question G. Okay. So I hope you're all in this page now, 133. They ask you to explain. Okay, this kind of question, it used to come out in the SPM, past year question, which carry 4 marks, 4 markah. Okay, 4 marks in the essay, a short essay question in section B, paper 2, section B. They ask you to explain how the bright and dark fringes produced by the ripple tank. Okay, so actually, if you look from the side view, this is how the water wave looks like. Okay, it is consists of a crest and trough, where actually the crest is act like a convex lens. Okay, you can see the shape of the crest. So our convex lens, dia convex macam ini. Okay, convex lens is thicker at the center and thinner at both edge. Okay, so this is convex lens. So the crest act as a convex lens. So what does convex lens do when light passing through it? Okay, can you answer that? What will happen to the light which pass through a convex lens? The light will be what happens?
Focus on one point.
Yeah, come again.
The light will focus on one point.
Yes, very good. The light will be refract and it will be converged or focused at one point, as seen here. Okay, so parallel ray from lamp converge and produce bright fringes. So you can see what happened to the light after passing through the crest, which is act like a convex lens. So it will focus or converge on a point. So this is where the part the light assemble at. So it will produce a bright fringes since a lot of light are focusing here. So it will produce a very bright fringes. And then what happened at the trough? Okay, now the trough acting like a concave lens. So where is our trough? Here, the valley. So you can see the trough. This is how concave lens look like. Okay, it is thinner at the center and thicker at the edge. So what happened to light when passed through concave lens? There will be refract and diverge out. All right, it will be diverge. So you can see that all the light diverge. So very few light, okay, drop here, so it will produce a dark region or dark fringes. Okay, so I hope you're clear with this, how the bright fringes and dark fringes appear from the wave producing by the ripple tank. Okay, so the parallel ray from the lamp diverge and produce dark fringes. So are you clear with this point? Explanation on bright and dark fringes produced by ripple tank, students? Okay, no problem. Like it's all to do with the crest and trough, which is acting as convex and concave lens respectively. Okay, where convex lens converge the light into a point, producing bright fringes, while for the crest, acting like concave lens, diverge the light, so producing dark fringes. Okay, so I think we can move to question 2. We are done with question 1. Okay, now question 2 again. It shows the diagram shows reflected water wave pattern. So you can see this is the diagram related to the question. This is our barrier or obstacle. This is the incident wave traveling at this direction, where you can see there is an angle of incident there labeled with I. Okay. And then after touch the surface of the reflector, it will bounce. Okay, bounce at the opposite direction. So this is the reflected ray. Okay, traveling at this direction with angle of reflection R. Okay, angle of reflection R. Okay, OZ is Ong Cheng, yes, I know. Okay, are your mic function, Ong Cheng? Is your mic functioning? Okay, then students, what is the question that follow? Okay, they give you this table for you to complete with. They give you the characteristic of wave. Okay, they give you the characteristic of wave, where the first one is the wavelength, followed by frequency, the wave speed, direction of propagation, and the velocity. Okay, velocity. So you have to complete, okay, the table. What changes occur after the water wave undergo reflection? Okay, and write the reason as well. So the first one, wavelength changes or not. So it's written here, wavelength does not change. So you can see lambda 1 equal to lambda 2, the distance between wavefront, consecutive wavefront, or the length. So it is not changes. Why not changes? Because the depth of the ripple tank is the same. Okay, the wave, incident wave, and the reflected wave have a same depth. So if depth does not changes, so do the wavelength. It remain same. Okay, and then the frequency. What do you think about the frequency? Change or not, students? Frequency of the incident wave and the reflected wave. Are they changed or not? The same? Okay, are they same or not? The frequency. Frequency will be,
Unchanged.
frequency will be remain unchanged. Why frequency remain unchanged?
Same source.
Same sources, yes, because both incident wave and plane wave, incident wave and reflected wave are producing by the same vibrator. Okay, same sources. So that's why the frequency does not change. So you write there unchanged because same sources of wave. Okay, and then how about the speed? Okay, the speed also does not change because the wavelength does not change, and so do the frequency. Okay, we have seen wave with us here. Okay, so why speed does not change? Sama juga because of the same depth. Depth does not change. Okay, or you can also say wavelength does not change. Okay, then how about the direction? Remember, direction changes. Okay, you can see initially it travel to the right, the incident wave. So after reflection occur, it travel to the south, to the bottom. So definitely direction of propagation changes. Why? Because the wave undergo reflection. Okay, the wave has been reflected. Okay, then velocity. Okay, velocity changes because velocity is a vector, remember? Okay, even though the magnitude is similar to the speed, but velocity changes due to changing in direction. Okay, so I hope you're clear with that. Okay,
Teacher,
direction change.
but there.
Direction, ini salah. Direction
Okay.
change. Sorry ini change. Wrong typing there. It's supposed to be changed. Okay, direction of propagation changes due to reflection. Okay, okay. Thank you for allowing me, Nicholas. Okay, so any more, problem on this? So I hope you're done with number 2. Very simple to understand. Just fill up the table and write the proper reason for each. Okay, so the only thing that changed for reflection of wave is direction of propagation and velocity. Okay, changing in velocity due to changing in direction, since velocity is a vector quantity. Okay, very good. Okay, now let's check on the next part. Okay, next part is number 3. You can see right there, they give you the step to draw reflected of water wave pattern from number 1. Okay, step to draw reflection of wave. Okay, first you draw the direction of propagation of the incident ray. This one is stated earlier. We have discussed in the previous lesson. Second, you can draw the normal line. And then third, draw the direction of propagation of the reflected wave. I'm reading now from page 133, okay? And then next, draw the wavefront, which is perpendicular to the direction of the wave. And then finally, check for the characteristic of the reflected wave. So according to this, you have to complete the draw pattern of the reflection of wave shown in this table. So for those who didn't do yet, I hope you can complete your diagram now. So the first pattern, what do we have? We have a plane wave. Okay, we have a plane incident wave traveling at this direction, and it hit a plane reflector. Okay, here we have a plane reflector. Okay, plane reflector or straight reflector. So you will see that the plane wave will be reflected back at the opposite direction. Okay, where the wavelength and the pattern does not change. To, to differentiate which one is incident wave, which one is reflected wave, you can draw with a different color. Okay, you can use different color. Let's say the incident wave we draw with red color. So the red line show my incident wave. Okay, so it goes in this direction. Okay, then you can draw the reflected ray using another color, reflected wave. Let's say I'm using blue. So this is how I differentiate my incident and reflected plane wave. Okay, so I hope you can do the same. Okay, who else in the studio? Okay, Ong Zheng again. Okay, students, so I think the first one, no problem. This is the basic. We have a plane incident wave fall on a plane reflector. So the reflected wave will also be a plane wave. And then B, again, we have a plane reflector, but we put it in a slanting position in a certain angle. Okay, at an angle of 45 degree. So this is our incident wave traveling at this direction. So once it hit the reflector, it will be reflected to this new direction. So when you draw the distance between the two wavefront, make sure it all has the same distance. If you draw here 1 cm, so all must be 1 cm. Same goes here. Okay, ini must draw 1 cm only because wavelength does not change. Okay, if you draw 3 line here, here also supposed to be 3 line. 5 line here, you're supposed to draw here 5 line. Alright. Okay, that goes for B. We use a plane reflector placed at a slanting position or at a certain angle. Okay, and then now in C. So in diagram C, we are using now a curve reflector. Okay, we are using curve reflector. Okay, curve reflector. And we have a plane incident wave. Kita ada plane wave traveling towards the curve reflector. So this is our incident wave. Okay, traveling at this direction. Okay, red color itu incident wave. And then after bounce off from this plane reflector, so it travel in the opposite direction to the front. So this is our reflected wave. You lukis macam ini. Okay, this is our reflected wave. After passing the focal point, so it will changes into this pattern. Okay. And for the fourth diagram, again, we have a plane reflector here. Students, you can see the black is plane reflector, but now we have circular wave. Okay, we have circular wave traveling towards the plane reflector. So this is our incident wave. I draw to you the incident wave with the red color. Okay, so this is our incident wave. Okay, it comes from the circular dipper or circular vibrator. So it travel in this direction and finally it will be reflected or bounce off from the surface of the plane reflector. So the blue one is the reflected wave. This is the pattern. Okay, this is the pattern of the reflected wave. Okay, traveling at the opposite direction. Okay, ini the direction of the reflected wave. So you can complete your drawing and the final diagram for E. Okay, so we have a plane incident wave here. Okay, this is our incident wave. We have a plane incident wave. The red line traveling at this direction. and it hit a curved reflector. Okay, it hit a curved reflector. So how's the reflected pattern of the wave will be? So this will be the reflected wave. Okay, the blue circular wave. Okay, and this is the direction of propagation. Okay. So I think for KSSM, they are not going to give you a curved reflector because on the textbook, they only discuss for plane reflector. But in any case, anyhow, you meet this question in the future. So I hope you know how to draw the pattern of the reflected wave passing after hitting the curved reflector. First and foremost, you must identify either the incident wave is a plane wave or circular wave. So you can study the pattern here. But we are more emphasizing on the plane reflector or KSSM. Okay, students? Reflected wave follow the reflector. Yeah, for curve reflector, it follow the shape. Yeah, for curve reflector. Yeah, for plane also, yeah, because the shape is plane, so it follow the shape of the reflector. Okay, Nicholas? Okay, then students, can we check on reflection on sound? So we are finished with reflection of water wave. So I hope you're clear with that. So now let us continue with reflection on sound wave. So reflection on sound wave, you can see diagram 5.15 on page 134 represent the apparatus and material for to study reflection of sound wave. Okay. So these are the questions that follow based on the diagram on 5.15. So these are the information you have to complete with. First, sound wave from the stopwatch experience what after striking the smooth wood. So the smooth wood is acting as a reflector. So it undergoes reflection. So the sound wave experience reflection. Okay, sound wave experience reflection. Okay, then what's next? For B, angle of incident. Okay, angle of incident is always the same to the angle of reflection. Remember students, for reflection of any kind of wave, either water wave, sound wave, light wave, I always equal to R. Okay, angle of incidence always equal to the angle of reflection. Okay, and then C, reflection of wave obey law of reflection. Okay, kita ada law of reflection. I believe you have learned before in lower form, law of reflection. Okay, it has two conditions it must obey. The first condition, who knows? What are the two conditions stated in law of reflection? Anyone? Anyone know the two conditions stated in law of reflection? Okay, boys, girls, anyone know the two conditions stated in law of reflection? Number one, it states that all the incident ray, the reflected ray, and the normal lies on the same plane. Okay, all the incident ray. Okay, this is the surface. So all the incident ray, the reflected ray, and the normal lies on the same plane. This is the first condition. Condition number one. Incident ray, reflected ray, and the normal all lies on the same plane. So this is the plane. It meet all in this point. Okay, second condition, I always equal to R. Angle of incidence always equal to angle of reflection. So I hope you remember these two conditions which state in reflection, law of reflection. Okay. Okay, and then we proceed with question D. Sound wave. Sound wave can be easily reflected by what surface? Hard and smooth surfaces such as wall, ceiling, and seabed. Okay, wall and ceiling has a hard surface. It can reflect sound wave. Okay, seabed with a smooth surface also can reflect sound wave. Okay, no problem. It can be reflected on both hard and smooth surface. Okay, then next E, reflection of sound wave on the hard and smooth reflecting surface producing echo. Okay, so let's say we have both hard and smooth surface, so the sound wave will be reflected at different time. So reflected at different time, which means it will undergo multiple reflection. So multiple reflection of sound wave are also known as echo. Okay, simple, right? Okay, then we check on the next part. Okay, next part is the application. Students, remember you have to know a few application of reflection of wave. So the first application you can see here, we apply in telecommunication system diagram for 5.16. You can see there is a parabolic antenna. The parabolic refer to the shape. It has a parabolic shape. Okay, and this is the signal receiver, and this is the parabolic disk. So what is the information there? Telecommunication satellites emits radio wave or microwave. So these are the two types of wave generally used for telecommunication, radio or microwave. Okay. And then second, when the wave hit the antenna, it will reflected to the receiver. So the hit from where? From the satellite above there. So when the wave hit the antenna, it will be reflected to the receiver. Okay. And then the third point, the receiver should be at the focal point. So if you look at this diagram, we place the receiver at the focal point, at the center, at the focal point of the parabolic disc. Okay, why place at the focal point? Because there is the point where all the signal will be converged at. Okay, all the signal will be converged at the focal point. So you will receive the stronger signal at the focal point. Okay, then finally, diameter of this should be bigger diameter. Why? To receive more wave. Okay, if you notice, sometimes this question come out in a long essay question, carry 10 marks. So you have to justify the suitable characteristic of the parabolic disk to be used in a telecommunication system, 10 marks. Okay, so this is a few characteristic and aspect which is normally discussed. The position of the disk, where to place, and then the size of the parabolic disk, why must be bigger. Okay, and then next, second application is on medicine. Okay, medicine field on as seen in diagram 5.17. Okay, so do you think, do you know what is the name of the devices related to reflection of wave here, students? Anyone? What is the name of the apparatus or devices related to reflection of wave here in medicine field as shown in diagram 5.17? It is the, what is the name of the device? Anyone? It is ultrasound. Okay, ultrasound scan. Okay, ultrasound, which is used to examine the condition of the fetus inside the mother's womb. Okay, the name of the device is ultrasound. So we have transducer. Okay, if you look at the structure of the ultrasound, it has a transducer which is used to transmit the ultrasonic wave, okay, into the mother's womb. Okay, and then from there, the rebounding echoes inside the mother's womb. It is consists of muscle, soft tissue, and then hard tissue. So there are multiple layers inside with the soft and hard surfaces. So the ultrasonic wave will be reflected multiple times. So it will produce echoes. Okay, so the rebounding echoes of the wave detected to form a picture of the features on a computer monitor. Okay, so this is how we are using ultrasound scanner, which is using ultrasonic sound wave, ultrasonic wave. Okay,
Sure.
yes.
Why the the ultrasonic wave doesn't reflect the shape of the blood vessel?
Doesn't blood vessel
Yes, reflect the shape of blood vessel
inside the womb
because
got blood vessel there? Mana?
because teacher are using type of care.
Okay, no problem. Yeah, continue with your question. Haha, why ultrasonic wave does not reflect the thing before baby?
Something like blood vessel or
Uh-huh.
skin or tissue because baby
Oh,
inside
why?
the yes.
Because it will reflect the solid particle condensed. Okay, the baby structure is very condensed. Okay, haha. Compared to the other things inside, which is not as solid as the baby's structure. So that's why it will reflect the whole image, the whole shape of the baby. Got it, Nicholas?
Oh, okay.
Uh-huh. Okay. Because of the density, okay, it is condensed, so the image will be clearer compared to the other image. Actually, you can see another image, but it will be quite blurred, okay, because of the as I mentioned just now, the density, okay, because of the condense of the baby structure. So am I answering your question? Is it?
Yes, yes, yes.
Okay. Okay. Then number three, we have another application which is sonar. Okay, remember students, sonar stand for? Who remember what sonar stand for? For arcade, for Baiduri, for citrine. Okay, what does sonar refers to? Sonar refers to sound. Okay, sound, navigation, and is for navigation and ranging. Okay, sonar, sound, navigation, and ranging. So this is a technology using a phenomenon of reflection of wave. Okay, so the wave is used. We are using ultrasonic wave in sonar. Okay, we are using ultrasonic wave in sonar. And this is the purpose of using sonar or the ultrasonic wave. First is to measure the depth of the seabed. Okay, to measure the depth of the sea. And then another uses is to locate the position of the object under water. It can be fish, it can be coral, it can be shipwreck, it can be any treasure, it can be submarine, okay, or anything below the deep water surface. Okay, we have TX here. Who is TX? Can you identify yourself? Okay, then I hope you're clear with sonar. Okay, then we go to the last page for today, exercises on reflection on wave on page 136. Okay, 136 students. Okay, here another diagram for sonar. Okay, you can see this is the generator or the transmitter. Sometimes it is called as a transmitter. So how the ultrasonic wave used to measure depth and to detect objects. So this is how the sonar function. It has a few structure, namely as generator. The generator consists of transmitter and receiver. Okay, so the transmitter sending the incident wave, the signal. Okay, the incident wave ini is the bold line ini traveling at this direction. Okay, ini the incident wave. And then once it hit the seabed or any object down there, it will be reflected back. Okay, so the short wave ini yang I draw with the blue line ini, this is the reflected wave. So the reflected wave will be received by the receiver. Okay, transmitter send the incident wave and then receiver receive the signal or reflected wave. So what to fill up here? You can see the point on this column. First, generator emits ultrasonic wave. First and foremost, you must know what type of wave we apply in sonar. So it must be ultrasonic wave. Generator is a curved surface. I'm not sure how the surface look like, but it shows that it travel as a circular wave because of the very high speed and very high frequency. Okay. Okay, then what's next? Second point. So this wave will be reflected. Okay, first it emits ultrasonic wave. Okay, and then second, what happened? The wave is reflected by any object below or by the seabed. Okay, and then what's next? The hydrophone. Hydrophone or the receiver. Okay, sometimes it is known as receiver. The hydrophone or the receiver receive the reflected wave and converts them into electrical pulses. So there is a screen here where the pulses appear here. Bila ada object, so later on they can estimate from the distance between two peak pulses, so they can calculate what is the depth according to the time they are sending and receiving the signal. Okay, and the next, the depth of position or object can be calculated using this formula. So this formula you must keep very well in your mind. Okay, D is the depth, V is the velocity of the wave, T is the time interval. You know already why divide by 2, right? Because we consider that the wave traveling and back at the time required for the wave to travel to and back is the same. Let's say it travel in 10 seconds, going back also 10 seconds. Okay, so for one way, we divide by 2, which is, and second to find the depth. Okay, then the next one is a calculation. I think uji kendiri 5.3.2. Okay, the last part for reflection exercises. Okay, students. Okay, this is the diagram you are given with as your stimulus. Okay, the diagram shows reflection of sound wave when it strikes on a concrete wall. So this is the incident wave and this is the reflected wave. Incident wave, reflected wave. Okay, then what is the question asked? You have to state the physical quantity which change. So remember, we are dealing with reflection. It doesn't matter reflection of light, water, or sound. You must know what is the characteristic of wave after they have been reflected. So which characteristic changes? So I hope you know this already. From the table we fill up earlier, the only thing that changes is to direction of propagation and also velocity. So direction of propagation and velocity. Okay, you write direction of propagation is enough. Same do with velocity, enough. Okay, and which physical quantity does not change? So frequency, wavelength, wave speed remain constant, unchanged. All right. Okay, then next question, question 2. You are given a diagram. It shows a bat transmitting ultrasonic sound wave directed to a moth in the dark. Okay, moth itu is like a butterfly. Okay, then after 0.08 seconds, the bat detected the reflected wave. Calculate the distance of the bat from the moth. Where given the velocity of the ultrasonic sound wave is 1560 meter per second. So we have a bat here, as shown in this diagram, is sending a signal. So in front there is the moth, a butterfly, and then he received back the signal 0.08 second after. Okay, after 0.08 second. Okay, then what is the distance between the bat and the moth? So we are looking for the distance. Okay, So this is the information you are given with. So we apply this equation. Okay, we are looking for distance. S itu distance no. Okay, S. So we rearrange the equation. Okay, so where S is VT divide 2. Sometimes it is given as D. Sometimes it is given as S. Kadang-kadang dia bagi D equal VT divide 2. Sometimes it did S equal VT divide 2. So you must know D and S is the same thing. Distance or displacement. Okay. So we just do the substitution. Velocity is given 1560. This is the time 0.08. 2 and 4. So divide by 2. By this, the distance between the bat and the moth is 62.4 meter. Yes, very good. Sin TX is sin way, is it? Is that you? Okay, 62.4. Don't forget the unit as well. Alright. Okay, so students, the last question for reflection. Okay, here we have question 3. Ultrasonic wave emitted from bottom of ship to seabed detected by the detector after 0.8 seconds. So you have to highlight the information. Okay, so we have to find the depth. Okay, find the depth of the sea if the velocity of the ultrasonic wave is 1500. So they give you this. Ini V velocity and this is T 0.8 second. So we are looking for D depth. OS. Samalah juga guna. So from D equal VT divide 2. So we do the substitution here. V 1500. T 0.8 divide 2. So the distance or the depth of the seabed is 600 meter. Okay. So are you doing good so far? Those in the live chat. Okay. You have anything to ask, you just have to type there so I can read it for you. Okay, those in the studio, you can open your mic or you can type on the private chat. Okay, then B. Now find the wavelength. The wavelength, so wavelength is lambda. We are looking for lambda. Okay, if the wave frequency is 50 kilohertz. So 50 kilohertz ini frequency F. Before that, you have to convert. This is kilohertz. Convert it into hertz first. So 50 kilohertz mean 50,000 hertz. 50,000 hertz. 50 kilo. Okay, please be alert with the unit you're given the frequency. So what is the relationship between F and lambda and V? Okay, earlier we know V. So we can relate a V equal F lambda. Okay, so this is the equation we can use to find the wavelength, where V is the speed or velocity, F is the frequency, and then lambda is the wavelength. So we do rearrange this formula, so it will become lambda equal V divide F. So we leave lambda here, we bring F to the other side. That's why divide. Sometimes your student fail to do this rearrangement, which is very bad. Okay, simple mathematics. So we know what is V. V is 1500 and F kilohertz. Remember, it is 50,000 hertz. So you will give lambda, you will find lambda is 0.03 meter. Okay, this is the wavelength of the ultrasonic wave use. Okay, so I think that's all with these exercises on reflection of wave. So what do you think about reflection of wave? Can you deal with them? Students, boys and girls? Any idea about anything you would like to comment on reflection? Or anything you would like to share with your friends? What do you understand in these subtopics? Anyone would like to share? What do you learn in 5.3 reflection of wave? Sinwei, can you share? What have you learned in this content standard 5.3? Or Nicholas, you want to share with others? You can open your mouth so everyone can hear you. Okay, come on class. Or those in the live chat, you can share what have you learned in content standard 5.3. Okay, come on, students, propagate, stationary wave, circular wave. Anything, any part you think which are a bit difficult in this content standard? Reflection of wave. So many wave must learn. 3 wave only, light, sound and water. Yeah,
Teacher,
draw. Yes.
uh, refracted and reflected. Now we only in reflected.
Now reflection. Reflect. Okay, bounce off. Okay, reflect.
Okay.
Travel and go. After this, we are continue with refraction. 5.4. Okay. So any more you would like to ask students for Akhir for Baiduri for C3? Now it's already 11 past 22. So what do you think? You want to stop here or you want to continue a bit with 5.4, refraction of wave? Huh? You want to stop here or you want to continue with refraction of wave? What do you say? The rest of you. May I
We
see
need
any
a
comment?
rest.
Yeah?
We need a rest.
You need a rest? Stress? Stress ke? Sinway. Who is this TX? Is it that you, Strinway? The rest of you, what do you say? You want to continue with refraction or we continue by tomorrow? Refraction of wave. This is another phenomenon involving light, sound, and water wave. You nak sambung sekarang ke? You nak sambung besok? Which one is your choice? Anyone? Okay, so I think we stop here for today. For the sake of your for the sake of my students. Yeah, so I give you a time to rest. Okay, Alvin also say rest first. Okay, no problem. So I hope you have completed with all exercises on reflection in our workbook. Started from page 133, 132 until page 136. Okay, take your time to digest with a constant standard and you can check back on this video if you miss any part of the answer. No problem at all. So I think we continue tomorrow with the new content standard 5.4, refraction of wave. refraction. Okay, refraction of it tomorrow. So I think see you tomorrow at when? What is the time? Forgot the schedule already. What is the time for our lesson tomorrow? It will be 11 past 30. Am I right? Is it 11 past 30? Okay, so class, thank you very much for joining me. Don't forget to fill up the attendance form. Okay, and do revise this lesson. If you have any question, you may ask me, you may be emphasize, or you do any exercises, you can ask me to check, but please don't ask me to check the whole book. I'm afraid I don't have enough time to check. But okay, you do a few questions, any part you didn't do, okay, you can ask me to assist you. Okay, tapi janganlah buat satu buku dan minta cikgu check. Cikgu takut tak sempat nak semak because I'm quite busy now with JPN and PPD program. Also, I have to give a commitment to other organisation also. Okay, so that's all for today. Ada dekat komen. Okay, dekat komen Cikgu pin at the comment section there. This one attendance form. You can get them from the live chat. Okay, here is the link. Okay, got it, Sinway? Okay, by that, thank you. See you tomorrow. Have a good day ahead. Okay, bye-bye, everyone. See you tomorrow.